Welcome back to the deep dive. So today, we're looking at something that sounds, well, really simple on the surface.
Deceptively simple.
Right, just monitoring a door. But we're going to get into the pretty incredible engineering that's required when that door is in an environment that's basically trying to destroy any tech you put near it.
Exactly. We're looking at a source on the NTI E-DCSR-U rugged door contact sensor. And we're not just, reading off a spec sheet here. The mission is to really understand why this kind of specialized tech is necessary where normal electronics would just, fail.
Okay, so let's start right there. I mean, why not just use a standard sensor? What's the main point of failure in these big industrial places?
It really just comes down to physics.
Yeah.
And, frankly, abuse. This is a floor mount switch, an industrial grade one.
Floor mount. Okay.
Yeah, and it's for huge overhead doors where you have like forklifts, heavy pallet jacks,
Yeah.
just constant heavy traffic. A normal plastic switch, it would get crushed.
It wouldn't last long.
Not at all. It would be degraded almost immediately.
So how do you engineer a solution for that? Because this thing has to be reliable, right? For years.
You solve it with just brute force construction.
Yeah.
It's got this heavy cast metal housing. It's basically built like a tank.
Ah, okay. Makes sense.
And it's not just the housing. To keep the signal safe, the connection itself is armored. It has an integrated stainless steel armored cable.
So the whole package.
The whole thing is designed to just shrug off impacts, pressure, corrosion, you name it.
One spec in the source really jumped out at me. It mentions a wide actuating gap up to 2.5 inches.
Yeah, that's huge.
It is. For a security sensor, that seems like a massive margin. Why would you want it to be that wide?
That gap is actually, I think, the most brilliant part of the design. It's where you see the engineering trade-off. You're sacrificing, pinpoint sensitivity for industrial reliability.
To avoid false alarms.
Exactly. Think about a giant warehouse door. It is never going to be perfectly aligned. It might be a bit loose or damaged. It might even shift a little in high winds. That wide gap is engineered specifically to ignore all that minor movement. So you only get an alert when the door is actually open in a significant way, not just rattling.
And that reliability also extends to temperature, too. I saw it can operate from minus 40 degrees Fahrenheit all the way up to 150.
Oh, absolutely. That means it's ready for a walk-in freezer or, right next to a boiler room. That operational envelope is key for these extreme environments.
Okay, so you have this incredibly tough piece of hardware that can survive pretty much anything. The next question is, how do you actually get the data from it? How does it communicate? I'm guessing it's not on Wi-Fi?
No, definitely not. It's all hardwired. It connects directly into a central monitoring platform, in this case, NTI's EnviroMUX systems.
And there's some flexibility in how you connect it, I saw.
A lot of flexibility, yeah. You can use a standard digital input screw terminal or just an RJ45 sensor port. It also supports both normally open and normally closed circuits.
So for anyone listening, why is having both of those circuit options so important?
It's all about making it easy to integrate into whatever system is already there. It means the sensor can work whether opening the door is supposed to complete the circuit or break the circuit.
So it works with modern systems and
older legacy infrastructure.
Yeah.
Exactly. And what's really crucial for these huge commercial sites is the cable length. You can run the cable up to 1,000 feet.
Wow.
Which you absolutely need if you're trying to cover acres of property from one central monitoring system.
So the big takeaway here seems to be that even for the most basic task, just watching a door, the engineering has to get incredibly specialized and, robust when the environment itself is hostile.
That's it. And, if we pull back a little, it raises a really interesting question for you to think about. The source also lists other related NTI products, like rugged sensors for vibration, for dust, and for noise levels.
All for these same kinds of harsh settings.
Right. So here's the thought. If a simple door requires heavy cast metal and a 2.5-inch gap just to work reliably, what level of specialized sensitivity is needed to accurately monitor something way more abstract, like subtle vibrations or tiny dust particles in those exact same tough environments?
That's a great question to chew on.
Something to ponder until our next deep dive.